In number theory, we have these numbers known as wooden numbers. Now, these numbers are numbers that have the following form: n times 2 to the n minus 1, where n is a natural number. So any number which has that particular form is known as a wooden number, and any wooden number which also happens to be a prime number is referred to as a wooden prime. So let's recap the definition of Woodall numbers. So if we have Wn is equal to n times 2 to the n minus 1, where n is a natural number, then if we stick n into this formulae, we'll be able to produce Woodall numbers. So let's generate the first few Woodall numbers. If we put in n is equal to 1, you will just get 1 times 2 to the 1 minus 1. So that is just 2 minus 1, which is 1. For n is equal to 2, we get 2 times 2 to the power of 2 minus 1. So that's 4 times 2, 8 minus 1 is equal to 7. N is equal to 3 gives us 3 times 2 to the 3 minus 1. So that's 8. 8 3s are 24 minus 1 gives you 23. For n is equal to 4, we get 4 times 2 to the 4 minus 1, which when you do the calculations will give you 63. For n is equal to 5, again you get 5 times 2 to the 5 minus 1, which will give you 159. And let's do one more. With n is equal to 6, we get 6 times 2 to the 6 minus 1, which gives us 383. And we can carry on in this manner. So the question is that these are Woodall numbers. These are the first few Woodall numbers. How do we get Woodall primes? So that's the question. How do we get Woodall primes? And that's fairly straightforward, because any Woodall number which also happens to be a prime number is a Woodall prime. So let's try and identify the first few Woodall primes. So 7 is a prime and it also is a Woodall number. So 7 is the first Woodall prime. Then 23 is the next Woodall prime. Then 383 is the next Woodall prime. So that's the first Woodall prime, that's the second Woodall prime, that's the third Woodall prime. And we're going to leave you with a question. And the question we're going to leave you with is, what is the next Woodall prime? So 7 is the first one, 23 is the second one, 383 is the third one. What is the fourth Woodall prime?